In this example, we are going to use transformations to generate the graph of g of x, and we notice that we are going to be starting with the parent function of y is equal to the square root of x, and we have memorized that this graph of rad x is going to look like this and have the points of interest being 0, 0, 1, 1, and 4, 2, and we're going to keep track of these points of interest as we perform our transformations. We've seen in previous examples that the order of operations for our transformations is that first we're going to apply all multipliers, and that's going to be stretches, shrinks, compressions, or flips. Those are all multipliers. And then we're going to do the shifting, which happens with the adding and subtracting. This time in this example, let's keep track of our points of interest also in this table, not just on the graph, but as well in the table. So the first thing that we're going to do is apply this outside multiplier. Now this time it has not just a 2, but a negative 2. And when we have a multiplier on the outside, we know that we are going to manipulate the y values in a logical way. This is a vertical transformation. And so what we're going to do to these y values this time, instead of just multiplying by 2, we can actually multiply the y values by negative 2 and perform not only the vertical stretch, but also the vertical reflection at the same time. The negative is a reflection and the 2 is a stretch. But by multiplying each of these y values by negative 2, we can do both of them in the same step. So our first ordered pair, 0, 0, the x value doesn't change when we perform this operation, and the y value is multiplied by negative 2, but that's still going to be 0. 0 times negative 2 is still 0. For our next ordered pair, we have 1, 1. When we multiply that y value by a negative 2 here, we see that the x coordinate is going to stay 1, but now the y coordinate is 1 times negative 2, or negative 2, which is down here. So my x coordinate is still 1 and my y coordinate is now negative 2. In our next ordered pair, we have the x coordinate is 4. It's going to stay 4. The y coordinate is going to now be 2 times negative 2, or negative 4. So we have both at the same time vertically stretched our graph out by a factor of 2, but also vertically flipped it. Now, this original graph was y is equal to rad x, but what this new graph's equation is going to be is y is equal to negative 2 times the square root of x, right? With that vertical flip and the vertical stretch. Now that we're looking at it from this table's perspective, we can see that what we're going to do to the ordered pairs here is that we're going to multiply the y values by negative 2, because these are on the outside. Multipliers are logical, so we're multiplying the y coordinate by negative 2 is going to not change the x, but 0 times negative 2 is still 0. And then y coordinate by negative 2, it doesn't change the x, but the y value is multiplied by negative 2. And multiply the y value by negative 2 here, it doesn't change the x, but the y value is multiplied by negative 2. And so these are the points of interest that we saw on the graph a moment ago. Now, because I'm running out of space, I'm going to erase that first transformation and do my next transformation in that spot. I like to perform the inside shifts next, but again, the shifts, the adding and subtracting, that can go in any order. It doesn't matter if we go right 1 and then up 3, or up 3 and then right 1. It doesn't matter, but I'm going to go right 1 first. And since this is on the inside, we know that we're going to be manipulating the x values in a backwards from logic kind of way. So from the equation, it looks like we would be subtracting 1 from those x values, but actually we're going to be taking each of the x values of this ordered pair and add 1. So we're adding 1 to this x value, adding 1 to this x value, and adding 1 to this x value, and that's going to take my graph to the right 1 unit. So add 1, we land here at 1, 0. Add 1 to the x value and don't do anything to the y. Add 1 to the x value in the next ordered pair, and we're going to land at two negative 2's. I'll just slide that over for a moment and then I'm going to erase it. But we'll add one to the x coordinate here and we're going to end up with 5 negative 4. We add one to the x, we don't do anything to the y, and now we've got these ordered pairs where we will connect our dots and graph our function down here. Let me erase this previous iteration so it doesn't get confusing. And the equation that matches our current graph is that we've already flipped it and stretched it vertically, and now we have shifted it to the right one. So we're ready for our last transformation, which is going to give us our final answer graph of negative 2x minus 1 and then plus 3. This plus 3, the last transformation that we have to perform, is a vertical transformation, right? So we're doing this guy that is vertical. It's going to affect the y values in a logical way. So we are going to take each y value and add 3 to the y coordinates of the ordered pairs. Before we do that, actually, let's catch up on our table over here. We just did the shift to the right, and in doing that we had to add 1 to the x values of the ordered pairs. Adding 1 to the x value of this ordered pair takes me to 1, 0. Adding 1 to the x value of this ordered pair takes me to 2, negative 2. And adding 1 to the x value of this ordered pair takes me to 5, negative 4. And we can see that those are the same points of interest that we had when we were looking at it from the graph perspective. So now we'll go ahead and add 3 to each of the y values of the ordered pairs. Now we're adding 3 to each y value because this is outside and logical. So a plus 3 does result in adding 3 to the y coordinate. So we're going to the y values, add 3 here, add 3 here, and add 3 here to get our new ordered pair. So our first order pair is going to go to 1, 3. Don't change the x, but add 3 to the y, so we land at 1, 3. Our second ordered pair is going to be where we don't change the x, so it's 2, is the x value, but we add 3 to the y value, which takes me to a positive 1. Negative 2 plus 3 is positive 1, so we say 2, 1. And then add 3 to the y value of our last ordered pair. The x value doesn't change, so it stays at 5. The y value, we add 3, so that goes to 5, negative 1. And we then connect our dots to complete the graph of this function. Back over here on our table, we would be finishing up minus 2x minus 1 and then plus 3, right? The x minus 1 is under the radical. And again, in order to get this transformation, we are adding 3 to the y values of our points of interest. So add 3 to the y value on this point, we're going to get 1, 3. Add 3 to the y value here, we get 2, 1. Add 3 to the y value here, and we get 5, negative 1, which are the same ordered pairs, points of interest that we saw on our graph. So we can check our answer on our calculator by going to y equals, inputting our function, so negative 2 times the square root of x minus 1, and then we get out from underneath the radical and we say plus 3, close her up, and graph it. And so far it looks like we're kind of in the right spot, but we want to verify our ordered pair points of interest by looking at second calculate, and then we choose the value feature, right? So hit enter while my cursor is on value, and then we plug in the x coordinates of our ordered pairs to see that our points of interest are correct. So I have 1, 3 on my graph, and 1, 3 is on the correct graph in the right spot. Now let's also check 2, 1. I just hit 2, enter, to see now that 2, 1 is a point on our graph, and then we'll check the third one by hitting 5, enter, and we see that 5 also goes with negative 1. So my 3 points of interest have been verified, and we feel good about this being our final answer graph.